this problem is come over here, scratch off C is 20, and we're going to label this as A. We're going to draw our triangle. Doesn't matter if it's drawn to scale or not, it's just for our visual. So we have A, B, C, we're given angle B is 29, we're given little b is 15, we're given A is 20. Okay, if we look at this from 15, as we go left from 15, when we start at one value, we have 15, then we hit 20, which is a side, and then we hit an angle. So we're looking at a side-side angle. Remember, these were starred. The possibilities, there could be 0 solutions, there could be 1 triangle, or there could be 2 triangles. So I always assume that there are 2 triangles, so I set them up by drawing 2 different pictures. And as I go along, if there's error, I just cross everything off and say there's no triangle that can be created, no solution. And then if I see the 2 pictures, I remember once I do one to consider what could the other look like. Is there another? Okay, so the givens are always going to be part of both of them. So they both have angle B, 29 degrees. They both have little b, side B. They're both going to have side B to be 15. They're both going to have, now that we said A is 20, they both have A 20. Now, if there are 2 triangles, what will be different are the remaining parts. So side C, angle C, and A. So same thing over here. This angle A, this side C, and this angle C will look different. Okay? So givens are the same though. So let's work with the one on the left. Right now, we want to work with little b over sine B because we have all that information. So little b over sine of 29 degrees is equal to, now the only other thing I have is little a, so I'm going to do little a is 20 over sine of angle A. So if I cross multiply, I would get 20 times sine of 29 is equal to 15 times the sine of A, angle A. We divide both sides by 15. And then A is equal to inverse sine of all this up here, this numerical value. So angle A is equal to 40.27. So I'm going to put that in right here. Now the second I find that second angle, what I'm going to do is put it in that first triangle, but then in the other, I'm going to do 180 minus 40.27. So in the other triangle, I'm going to put 180 minus that angle I just got, 40.27. This pen is not working. 40.27, and that would give me a different angle, 139.73. Okay, so when I have one angle given, side-side angle, I draw 2 triangles. I label all that's given in bold for both triangles. And then the remaining parts will be different if there are two triangles. What you're going to do is you're going to search for the next angle. And once you search for that next angle, in this case we got 40.27, we're going to then always do 180 minus that number, right? As long as that number, that angle is less than 180, we'd do 180 minus that and see what we get. And then we'd label that in that A spot in the other triangle. And then we'll go back to the left triangle and we'll search for angle C. So angle C would be 180 minus the two interior angles. Its triangle, 29 minus 40.27. And so angle C would be 110.73 degrees. So this is 110.73 degrees. And then if I go to the other triangle, this angle is going to be 180 minus its interior, 139.73 minus 29, which is going to be 11.27. And then for both, you're going to find their last side. So the one on the left, if I'm searching for little c, I'm going to do little c over sine of angle C, which on the left one, our angle C is 110.73, is equal to little c over sine C. We want to use one that we have, so I'm going to go with B, doesn't matter. So little b is 15 over sine of 29 degrees. If we cross multiply, we'll end up with C equaling, let's see. So I'm going to do sine of 110.73 times 15 divided by sine 29. So we get 28.94. So that's what this would be for the left triangle. Obviously for the right one, it's going to be different because we're working with different angles. So little c for this triangle over sine of 11.27 degrees is equal to, we can do little b over sine of angle B, 29 degrees. And if we cross multiply, this value will be 6.05. So for this triangle, 6.05. So this would be an example where there are two triangles. So that's why I like to draw the picture, or else sometimes people just draw the first and they don't think to consider the second one. And that's because we're only given one angle, right? If you're given two angles, there's only one option for the third. But if we're given one, then we have to consider the two different triangles that can be created. So ambiguous case is when you have, like we said before, when there's a side-side angle, there's the possibility, so there can be 0, 1, or 2 solutions, meaning those triangles that we could create, okay, because we only know an angle, we need to determine we need to determine if the other angle is acute or obtuse. Determine if the other angle is acute or obtuse.